Good morning, grade 10 students. This is Mrs. Pascal. Today's lesson is a quadratic formula and discriminant, Chapter 9, Section 9.6. The objective of this section is to solve a quadratic equation in the form of ax squared plus bx plus c equal to 0 using the discriminant. How can we solve a quadratic equation using the discriminant? A quadratic equation can have at most two real solutions. So to solve it using the discriminant, we need to use the expression delta equal b squared minus 4ac. If delta is a positive value, the equation admits two real solutions in the form of x1 equal minus b minus radical delta over 2a and x2 equal minus b plus radical delta over 2a. If delta equal to 0, the equation admits only one real solution in the form of x equal minus b over 2a. If delta is a negative or smaller than 0, the equation admits no real roots, or we can say the equation has no solution. Examples. Solve the following equations using the discriminant. Example 1. 2x squared plus 4x minus 5 is equal to 0. As usual, we need first to specify the values of a, b, and c. In this equation, a is 2, b is 4, c is negative 5. Then we need to calculate the value of the discriminant. The discriminant delta is defined by b squared minus 4ac. After calculating delta, we get 56, which is a positive value. So, from the value of the discriminant, we can deduce that the equation admits two real roots or solutions. x1 is equal minus b minus radical delta over 2a. By replacing b, delta, and a by their values, we get x1 equal minus 2 minus radical 14 over 2, or x2 equal minus b plus radical delta over 2a. Also by replacing, we get the reduced form x2 equal minus 2 plus radical 14 over 2. Example 2. For the equation x squared minus 2x plus 4 equal to 0, we need to find first the values of the coefficients, of the real coefficients a, b, and c. So a is 1, b is negative 2, c is 4. Then we need to calculate the value of the discriminant delta defined by b squared minus 4ac. And for this equation, the discriminant is negative 12. So we can deduce that the equation admits no real roots. Example 3. For the equation x squared minus 6x plus 9 equal to 0, after defining the real coefficients a, b, and c, delta gives the value 0. So the equation admits one real root in the form of x equal negative b over 2a, so x equal to 3. What's the importance of the discriminant? Using the discriminant, we can find the number of solutions for a quadratic equation, and we can determine the number of intersecting points between the graphical representation of the function, of the quadratic function, and specifically the x-axis. So when delta is positive or the discriminant is positive, we can say without graphing that the curve cuts the x-axis at 2 points, and by calculation we can find two real values of x. When delta is equal to 0, we can deduce directly that the graph or the curve cuts the x-axis at only 1 point, and by calculation we can find one real value of x. When delta is negative, the curve can be presented above the x-axis without cutting it, or below the x-axis if we have a maximum curve. And by calculation, we cannot define a value for x.